So yeah, we have to follow this etiquette. I think everyone is aware of etiquettes. I'll skip. Um, okay, today I'm talking about mastering AWS DynamoDB. I will. It's a very vast. It's a very big service. Okay, so I will try my best to cover most of the basic things, plus some advanced things. So I'll start with what is DynamoDB core concept, service integrations, then some hands-on demo, and at the end we need best practices because we all will, if we are working on some service, we need to know what is the ideal, what are some best practices which we should follow while creating new system, so the architectural decisions will be good. So okay, so let's assume we are creating a catalog management system. Okay, let's say there is a startup, e-commerce startup. It wants to create catalog management system. Of course, the first choice comes to mind is SQL DB, like any SQL DB, Postgres, MySQL, etc. And then as the size of startup grows, okay, also the, let's say it is a marketplace, so then the brands or merchants will grow as well, right? So which means the products, number of products will grow. It can cross millions. So what happens with typical SQL system is, RDBMS system is that once the table size grows, okay, applying join operations becomes latent. Basically, if you fire a query, it may take 1 second, which is of course not acceptable in current world, right? We if you milliseconds, that's it, right? So that is one thing, like join operations make query slower. Another thing is, we have to create many indexes, right? To make, like, how do we deal with that? We create new indexes so that performance will be better. After some extent, index size also gets huge, right? Like, you can't have so many indexes in one table. Also, if you try to add a cache layer and then keep the better try to keep the better performance, but then managing cache becomes so to so basically the problems are coming to three categories. One is latency, like we need high latency. Second is a scaling problem, like how do we handle millions of products or any data. Third is high availability. We also want to keep system highly available, right? So this is where AWS DynamoDB to picture it can it is SQL DB. Okay, so it is a schemaless.
Sorry to
It
interrupt,
does not.
Shruti. The network is still lagging and your voice is breaking.
Okay, I think I'll have to disable camera, or I don't know
Okay,
what
we
else
can
to do.
try that for now.
My screen is visible, right?
Yes. Just make sure to put it in the presentation mode.
Okay, yeah. Okay, so DynamoDB is fully managed. So let's break what is fully managed. So you don't need to um, provision any server or any cluster and think about how the data will be stored, what partitions will be there, etc. You don't need to do anything. Just create table, add data, and access data. Okay, so basically managing data and creating tables. So it's a fully managed fully managed serverless NoSQL DB. Okay, it provides single digit millisecond latency, so it's very fast. Okay, so it's better now. Is it better now? Is it breaking anymore?
No.
Okay. So it provides single digit millisecond latency. It can scale up to trillions of requests per day. Um, for solving availability problem, it provides us with global tables, which means that tables are replicated in multiple regions, so that we can have lower latency in all regions. Okay, comes with two options: pay per use and provisioned. Means if you have the idea that I will require these much memory in GB or TB, then you can provision the provision. You can provide provision data. You can also go with on demand. If you, for example, if there is a flash sale, you don't know what would be the traffic. For that type of scenario, you can use on demand usage. So it will scale automatically. It provides us with CDC support, which means capture data change. So every time the data is being added or updated, you will it can be like you will get that event, like basically this data is added or updated. So it provides us with CDC support. Based on that, so many other use cases can be handled. It comes with service integration. So many AWS services like S3, CloudWatch, Redshift, OpenSearch, all these are you can integrate directly, and you don't need much efforts to do that. It comes with backup and restore. We all know about that. And point in time recovery, which means like if you want to know that the 1 week before what was the snapshot of data, you can get that. So you can get it up to 35 days, like any snapshot before 35 days. Okay, which is a great feature. And then use cases are mostly as I said, wherever the scale is huge, and latency should be very minimum, and then cases
Shruti, we can't hear you properly.
financial applications.
Can anyone else also confirm?
One second, I'll switch network. Give me a second.
Okay, sure.
Hello.
Yes, Shruti.
Okay, so let me know if problem comes again. Okay, sorry for this. I did not anticipate this. Um, okay, okay. Is it good now?
Yes.
Okay. So okay, we'll go to next core concepts. So basically, there are three main concepts: table, item, attribute. Okay, These are the main three things: table, item, attributes. Table is similar to a SQL table. It is collection of items. uh, what is item? Item is similar to what we call row in SQL. It is it is basically collection of some attributes. Okay, so for example, if there is a table called person, then item would be like the details of one person. It could be a collection of attributes like name, first name, last name, full name, ID, etc. It could be nested as well, like it can have some JSON like structure. That is supported. And coming to attributes, attribute is basically a key value pair, like first name equal to Shruti. So key will be first name, value is the actual value. And here the important point is, it does not have rigid structure like SQL, right? Like if you have SQL table of person, if it has 10 columns, all person data should have 10 attributes. In the Dynamo, only the key attributes, okay, so which we will discuss now. So only the key attributes should have mandatory data, like data should be there. All other attributes are flexible, like you. That's why it is called schemaless. Like, uh, so consider in real world example like product. Okay, so if the product is a clothing item, then it can have some attributes like fabric care, fabric wash, etc. But then if product belongs to some category like shoe, then it will not have that type of attributes. This is the use case where schemaless nature helps. So now we'll discuss about keys. Okay. um, so we all know what is primary key, right? Primary key uniquely identifies the item, right? Let's say orders table will have order ID, then like each order will have unique order ID similar to person IDs, something. So now in Dynamo, it is known as, there are two type of keys available: partition key and sort key. Okay, so what is partition key? So partition key is basically, for example, let's say I take order ID as a partition key. So it behaves as primary key, right? And sort key is kind of optional. You can give, or you can skip. It depends on the scenario. Okay, so let's say you want uh, let's say sort. I'll give the example why when sort key is used. Okay, so let's say you want to um, list orders by date, for example. Okay, so basically you want dates, orders sorted in descending order by order date. So in that case you can use sort key as order date. So what actually is happening? So let's understand this in detail. So I'll quickly move to this diagram. Yeah, so this is how partition key and sort key works. So for example, we have animal type, and name, and then other attributes. Okay, so there is internal hash function. Okay, so partition key, let's say animal type is a partition key. It will be given as input to this hash function, and then hash function will calculate the partition number. Okay, so whatever this animal type will be calculated. For example, this partition 3, then it will be stored here. So all animal type having this value, dog value, will be stored in partition 3. So this is how it internally saves the data. So like this, each partition can go up to 10 GB. But let's say now partition is decided, but now you want capability to when you are retrieving the data, okay, so you want it in particular order, right? So let's say if animal type is dog, you want all dogs having name in sorted order, descending or ascending, both. So in that case, you can give sort key as name. So what it will do is inside a partition, it will save the data sorted by name. Okay, so that's why basically, if in a nutshell, I would say same sort key. Sorry, like depending on sort key, the items will be closer to each other, right? So coming back to this, so we'll take for more example as well. So basically, yeah, partition key decides the physical partition, and sort key decides the order inside the partition. That's how Dynamo works. And we can also call it composite primary key, right? So if you have, if you give sort key, it will act as composite primary key. If you don't give it, it will expect that partition key should be unique only. Uh, Coming to next point, which is table types. We have two type of tables, standard and standard infrequent access. So basically it is um, standard table is what by default option, like whenever you create new table, it will be standard, but you can choose this standard infrequent access in case your data is archival in nature, which means it is, you don't want to access it every day or every week, like it's there just for historical data, history purpose, then you can use infrequent access. So it is optimized for storage, so storage cost is lesser in infrequent access, but the access cost is higher. So that's how it's designed. Coming to supported data types, so here the data types are categorized into three category. First three, which are first four string number binary boolean, are scalar types. It is a single value. Then map and list, these are called document types because you can save uh, JSON like structure. So map is used for JSON like data, list is something like JSON array, right? So it is called document. And string set, number set, binary set, basically those are set types, and they they are useful when you want to save unique values without worrying about order. Then set type is used. So everything in Dynamo is usually eventually consistent. Okay, so let's say there are let's say there are concurrently writes are happening and then reads are happening. So read may not have latest data always, unless it gives you support, but then it comes with extra cost. So uh, usually Dynamo will is used for eventually consistent reads. Okay, so that is where that has to be in mind while designing a system. So okay, so this is visualization, like how it looks like. Let's say person ID, it's a partition key. Okay, and then it has attributes like last name, first name, phone. Okay, so if you see, there is a favorite color in 103, it's not there in others, it's a schema less. um, okay, so now we'll talk about a very important concept called global secondary index. Okay, so there are two type of index, local secondary index as well as global secondary index. So let's say you created a table called orders, and you decided partition key, which is order ID, sort could be order date. Okay, but now you also want to access data by customer, like you want all the orders of particular customer, right? So if you just have partition key and sort key, it will not work, it will not be efficient. Also it will scan full table, which is very costly. So that's why we need to create other indexes, right? So you can create two type of indexes, like global secondary index and local. So a global secondary index is similar to how original partition key and sort key works, but you can create other partition key, other sort key. So you can choose, like you can say customer ID should be partition key, and order ID should be sorry, customer ID, and let's say order date should be sort key. So independent of the original table keys, you can create few more index. It is similar to how you create more than one one indexes in SQL, right? You can create 5, 10, depends on your usage. So basically here also you can do same. Local secondary index, it only differs on the thing that it partition key, if you want a partition key to be same as the base table, but then sort key should be different. Okay, let's say you want orders by price, sorted by price instead of date. So you can create sort key, uh, uh, you can create local secondary index, order ID and price. So this is a example, this is an example. There is a table orders, okay, and you have to come up with query patterns. That is very important. So that's the most crucial part before creating table, that what would be the query patterns, because once you create table and you have assigned some partition keys and indexes, etc., and then your if your query pattern is different from what you initially thought, then it will go for full table scan and it will be very costly. So we, let's say we define query patterns like get order details with products, get customers orders sorted by order date, get orders by order date, and get all orders sorted by date. Okay, so these are the query patterns. So now let's see how we can solve this. Get order details with product, that is the first case, and this is the most used case. So we can define it as part of base partition key and sort key. So order ID, partition key, sort key, product ID. So the first pattern will be is satisfied now. Now you can query by this. Now we need to create global secondary index to fetch customers order sorted by order date. So customer ID and order date, right? And then third one, let's say we need get all orders. So yeah, this is a mistake. So okay, let's consider if we want order by sorted by price, then this local secondary index will be helpful. So we'll see demo. Okay, we discussed this already. Okay, we have 5 minutes. Oh, sorry, till we have 20 minutes, right? Okay. So I'll start with SDK demo. Okay. So we have I have I have used two type of libraries for demo. One is the uh, main AWS SDK's Java library. Okay. Another is Scala specific library, which is Scanemo. Okay. So you'll see the difference. This is a Java AWS Java specific library. If you see it, it's a little verbose. We have to use lot of boilerplate code, right? And this is a Scanemo. So Scanemo, it's a precise and there is no boilerplate. It's very readable. So let's try to create a table. So there is, we are going to create orders table. So first of all, how to connect to AWS Dynamo, right? So we have to create in AWS UI. We will have to create a user and create uh, access key, and we have to basically credentials. So it comes with access key and password. So it we have to save it something like in AWS folder, and in credentials it can be saved. So there are available commands to do this. You can check it out. So once it is done, okay, so now I am using that um, credential which is called practice, like I have given that name. And so let's see. So while creating table, what do you need? You need table name, which is orders. You need to give partition key and sort key. So I'm giving partition key here, order ID, and sort key giving as product ID. Okay. Then I am giving all the attributes. The order date, customer ID, order ID, product ID, of course. I am creating local secondary index, which is base order ID and order date. So if you see, order ID is already a partition key, right? That's why it is called local secondary index. And then uh, this is global secondary index. I'm using customer date index. So customer ID is partition key, and order date is sort key. Okay, so if I run this, so we see orders table is being created. Okay, it may take some time. Okay, so here you can see partition key, sort key as I requested, and there is customer date index. Okay, so now I'll try to insert data. What we are doing here is we are defining item basically in key value pairs, right? And then throwing put item request, right? So it will just create new entry using this put item. So this is basically SDK, AWS SDK code of Java. So yeah, I'll it's a inserted order this. Now I'll try to update. Is there an amount? I think I have. Yeah, amount is not there. So yeah, so yeah, that you can basically use this. Some like all CRUD operations are supported here. So client dot delete, put, get, update, etc. It's very works similar. Now coming to Scanemo. So this is simple, like you have this execute command. Okay, here you can provide the operation. So here, let's say you are saying that on this table I want to perform put, and it's a Scala wrapper, so it don't need extra code. So I'll just run this. Okay, now this is a crucial query order. So basically we want to use this index. So basically we want orders by customer sorted by date. Okay, so you have to provide like use this index and then write your query like customer ID is this. So now it will give you the required data, right? If you don't provide this, it will not, it will throw some error. So it will either expect the base, base partition key, which is order ID, or you have to give some index name. Then only it will use that. So, okay, this is a demo. So we did all CRUD operations except delete. I think that's very that that's also easy with this. So now coming to, let's check the UI. Okay, so here you have table which we saw already, then explore item. So you can if you see there are two options, scan and query. So scan is full table scan, costly. Ideally we should not do that. Query is the one we should always uh, try to access data through. Okay, so here if you say just if you give order ID, it will give the data. So yeah, so now I'll talk about all integrations, how data can flow through one from Dynamo to other system, other services. So there is a direct option of export to S3. You can also import from S3, and these are zero ETL integrations, which means your data can move from Dynamo to Redshift and OpenSearch as needed. You don't need, like, you need zero code to do this. And there is one more concept called streams, right? So this is DynamoDB stream detail. So this is what CDC I was talking about, change data capture. Okay, so if you turn on the DynamoDB stream and then you provide required like do you what exactly do you need, if you need all insert and updates happening as through events, then you can enable this new and old images, then turn on, and then the stream will be created, and then you can consume in your code, or through, let's say, AWS Lambda function. You can like create a Lambda function which consume this stream and export to somewhere else in S3, or uh, or any data warehouse solution where you want the data. So yeah, this is very important, DynamoDB stream. Moving on to okay. So library wise, I covered Scanemo, I covered Row, AWS SDK. There are other commonly used libraries which are Alpaca, DynamoDB. If you are in Akka ecosystem, you can check out that. For Zio also there is Zio DynamoDB. This is what I explained, DynamoDB stream. So any change flows through stream, and you can create consume as you want. This is also we covered. So now coming to best practices part. Okay, so first of all, you need before designing schema, the main crucial task is to define access patterns, like write down all the query patterns which are currently used, and in future if it might be used. So all query patterns should be written down, and then based on that, partition keys and sort keys, along with global secondary index and lower secondary index, local secondary index should be created. How to design partition key? Okay, so partition key should be chosen such that the data is distributed evenly across partitions. So for example, order ID is good um, good partition key, but let's say if you are planning to use some for, let's say, for catalog table, if you are planning to use company ID, which is like product belongs to which company, like it could be very limited, and like one company can have many products, right? So if you use company ID to decide partition, it will result into uneven partitions. Like one partition will have it will exhaust the usage of 10 GB, uh, uh, and some partitions will have very less data, which company has less products. So this problem is called hot partitions. Like some partitions are very used, like the queries are frequently coming for that particular partition. So that creates uneven distribution, and we should avoid that. That's a, it's a very important principle to before designing partition key. Sort keys should be used to organize your data. Okay, so if let's say in e-commerce we have user needs to give some filter conditions, uh, list products sorted by price, right? So that is the classic example where we should use sort key. So access will be very faster. So yeah, then how to handle large items. So let's say your product has very big large attribute. Um, for example, it has hundreds of images for single product, for example. Then it should not be directly saved to Dynamo. We should only save the pointer to S3 bucket, and save images to S3 rather than saving to Dynamo. So you have to we should avoid large data, huge data in single item. um, for time series data, it's recommended to use time to live property. So you let's say your website is saving all the clicks user has made, then the data can grow large in no time. So you have to like keep deleting the all data by setting TTL. We have 5 minutes, okay. And we have to model in such a way that joins are not there. Okay, so it's not like RDBMS that there we where we save data in normalized form. Here the priority is low latency, so denormalization is totally fine. Replication is like duplicate data is totally fine. So that joins are not there, data should be available in single table. um, Prefer query operations over scans, right, which I have already discussed. So if there is a scan happening, means it's not efficient. You will have to fix it. um, Design DynamoDB tables for your usage patterns. Okay. In global table design, plan for cross-region replication, conflict resolution, and data consistency. So you have to um, like you have to just decide the regions based on the user base, etc. And check how data will be consistent across, because it's very because the data is eventually consistent, but it should not be like um, it's coming like 5 minute, like the latency is as high as 5 minutes will be considered bad, right? So you have to design in such way that it's not very latency is not very high. And yeah, manage the control plane, which is basically table creation, index updates, etc., to avoid throttling, service limits. It's self-explanatory. And use bulk data operations. So yeah, we also have batch write, batch fetch, bulk export, import, all these available in AWS SDK as well as other libraries. And watch for your limits, otherwise it will start throwing errors. Yeah, that's it. If there are any questions, I'm happy to take. Okay, I think we are good. Thanks for listening.